Welcome to the project demonstration of underground cable fault location identification system using PIC microcontroller. So here the main advantage of this project is, as we know that whenever the underground cables are fault happen, then it's difficult to find the location of the particular fault. So there are so many number of faults, so like line to neutral and neutral to neutral, line to line fault and line to neutral fault and line to ground fault. So these are the faults. So now we are going to identify the line to line fault and also at which distance. So this is the transmitter section and this is the receiver section. So from this transmitter point, so we have located the short circuit switches at 10 km, 20 kilometers and 30 kilometers. And whenever the short circuit is happened, based on the length of the wire in real time, as we know that the resistance is proportional to the length of the cable. So wherever the short circuit is happened, then we are going to measure in the drop voltage, and based on the drop voltage we are going to calculate the approximate distance, and we are going to identify the at which location and at which line, so line to line fault. So by measuring the three phases voltages and drop voltage will be measured, and based on the calculation of the drop voltage we are going to identify the approximate distance, and that will be displayed on the LCD screen. The whole system run by our PIC 16F72 microcontroller, and we have interfaced this drop voltage voltage sensor data to the A0, A1, A2 pins and LCD at pin number B2 to B7. And on this motherboard there are the two LED indication, one is the power LED and one is the program LED indication. Whenever the fault is occurred, the so-called LED will be on, and this steel plated one is the crystal oscillator which will provide the clock pulse to the microcontroller, as the microcontroller need a clock frequency pulses to execute the instructions, as we provided the program instructions, and to execute them microcontroller need a clock pulse. Per clock pulse, per instruction will be executed. So initially the welcome message will be displayed, as if there is no short circuit from this PCB, that's why status is normal. And whenever it is short circuit happened, then R to Y, this is the R to Y connections and Y to B and B to R. So at 10 kilometers, and it is normal again. Okay, and again here it is 20 kilometers R to Y, and again R to Y fault at 30 kilometers. The same manner Y to B30 and Y to B20 and Y to B10. Okay, so here B to R 10 and B to R 20 and B to R 30 kilometers. So in this manner we can measure the distance based on the drop voltage, and the voltage will be drops based on the length of the cable. Okay, so whenever the length of the cable is more than kilometer wire, then only we can identify that very much easily, as we can get the less drop voltage based on the length of the wire. Right, thank you.